Howdy doody. I don't know why I put these on, by the way, because I don't have Discord running, so people aren't really talking to me through my ears, but I feel it's strange without those. So this is the first kind of from scratch type build I'm going to be doing. Well, I've got 5 minutes before I have to start officially. Look at that, he's so cute. And his steampunk brother. Coppery. I really am just going to set about trying to use this module. I'll just take the plastic off. One of those things. So those of you who've got the Backoffice boxes will know this is an LS2074M2G module, and we don't really know anything about it. So I'm hoping to try to do some sort of circuit with it. No, LS, bollocks, LS2074M2G. So we're going to do the effort today of actually finding data sheets for things too. I know I don't normally bother, but I don't really know too much about these. Oh, what? Lots and lots of cathodes here. Oh, that's it. That's the whole data sheet. Okay, so we've got 1, 2, 3, 4. So that's the top bottom. Yellow, red, green 1 and green 2. Okay, let's fire up Eagle. Come on. There we go. Sure, whatever. So this is our old project based on that single digit 7-segment screen. So I think we'll be basing it off that. So file, save as projects, new folder. LS2074M2 display. For M2G. Let's see. Yeah, I'm not sure I can actually do what I've just done in Eagle. Let's get that sorted out. So I hope you've all had an interesting Friday and that you're unwinding slowly. I'm trying to. Very agitated today, so I'm happy to be doing something like this to sort of chill out. Oh, okay, so we've got the board and the schematic in the same folder. Good, because the last thing we want to do is mess up. No, so we don't want to do that yet. I don't want to confuse Eagle, basically. Finally, right, so that's the old project. So I'm using the old project because I just want the pinouts basically. So I'm going to delete that. We don't need that. And we don't need that. We don't need these. We don't really need anything, actually. We just want the booby header, if anything. That'll do. So looking at this data sheet, we're going to have to make this part though. That's going to be a bit of a pain, but we'll do that. We'll have to make a new library. how do we bloody do this? God, it's so weird using Eagle from way back. Libraries, here we go. File, new, library. Now we should actually have a Backoffice show library because the baby boomer belongs in one. I'll just have a quick search for that before I start creating a new library. God, do bear with me. I know it's not the most fascinating part of a project, but this sort of general fannying around is the bit that's needed. Once you get it out of the way, though, normally it's not too bad. Normally. Here we go. Backoffice library. Yes. So I'm going to put that up front and center. So there's our Backoffice library file. So I'm going to make sure that Eagle is pointing to that folder. Bang. Bang. Libraries. Hopefully there'll be a Backoffice show library now. Backoffice library. In here. Hooray, finally, a Backoffice library. Good. Just going to give a quick shout out on Twitter. Seeing as it has just gone past the hour. Oh, Twitter, you piece of crap. Good. Got it out of the way, guys. Back on it. Okay. Where shall we start with this then? I guess... yeah, let's start with a symbol, I suppose. LS2074M2G. Yep, let's do it. There's our data sheet. I'm not sure on the scale, actually. It's been a while since I've done this. This might be too ridiculously big or too ridiculously small. Okay. Do you want to check it's the right? That seems okay. That's fine. Wire. Nets. Is that how we bloody do it? I feel now I have to load up something else just to see what I've done here in the past. Right. Oh, it's all on 94 and then you just add the pins. Okay, fair enough. So keep everything on layer 94 and we'll add our pins afterwards. Oh yeah, brilliant. So how many pins do we have on this? 28. So I'm going to need to make this beastie a lot bigger. We'll move that after around the center point. I don't think that's important right now. Just have to... howdy from Tokyo. Yeah, howdy to you too. Yeah, I should have been using Microsoft Paint though, shouldn't I? Just to be legit. 28 pins. I'm just looking at the data sheet here because we've got a bunch of common cathodes, anodes. ABC, and it doesn't even say what the segment is, but I think segments on these panels are relatively standardized. And I can see those of you on the stream, there's a sort of chat window thing going on, so I'll have to pop that there. Give you a chance to see that. So let's just lay out 28 pins really. No. 13, 14. This is going to be friggin' tedious. Yeah. Okay. Oh, fuck. It's a funny thing with PCB design tools that they're always so shit. Every single one of them, really. Let's see now. How are we going to... YC1? YA1? YC2? I should check there's a datasheet for this. Not a datasheet, an actual pre-made component. RC1. RA1. RC2. So any of you who've got this in your back office box, no, for fudge's sake. RA2. GC1. GA1. GC2. GA2. I'm wondering how this actually even relates. Let me just check this real quick, just looking at that. So that's all the things. So okay, hang on. Segment F. So the it's quite cool actually. So all the anodes for this 7-segment display are all multiplexed up already. That's going to be cool. I'm not actually sure what that means in practice till we actually get to it then. GC1. Fudge sake, what's this one? 13. Oh, G2C1. What the... Yeah, hi Fairfight, hi GQ, hi Brian Jones, hi Paul Bradley, hi everybody. I do apologise. I've not been I'm being tardy in my saying my hellos. My brain is addled right now. I'm really stressed out, and I'm trying to do some circuity stuff just to cool down, to calm my mind. So I'm just trying to look at this now, and I've chosen some nomenclature going down this. Like I've got my GC2 for my pin 11. For that's green. So there's two. Oh, so there's. I'm confused about this green one. Why is there why has green one got so many things? Oh, okay, I see. So these are, even though they're yellows and greens, they've got multiple things. Okay, right. So this is just a separate LED. So it's G2C1, G2A1, 15. Right. The noise box. Who are you talking to, Fairfight? Me. The noise box. What was the noise box? Remind me. You sent me something. AA. Digit 7 cathode. 7C. 18 BA 6C DA. This is the worst of it though. Get this out the friggin' way. 5C 4C 3C CA 2C GA. What have I done here? Too many pins? GA 27 1C I think that's it. No decimal points to worry about. Hey Tilo, hi super speed. I still have that hacking device that you sent me, and I haven't tried that yet, but that will be in a future video. Right, I think I've kind of laid out this, so I need to just move some stuff around. I want to move some stuff around. I'm gonna do, you know what? Bloody CAD. Let's get that out of the way. Get that all selected, shift that down, get that flipped. Yeah, that's looking pretty sweet now. Right, just get the label on there. LS207 4M2G. Names. I think that's it. That's pretty good. That'll do. That'll do nicely. Save that. So we've done the symbol. Now we've got to do the package. LS2074 M2G package. Yep. Excuse me 2 seconds. I need to get a vernier caliper. Shit. Busted my vernier caliper box in my haste. Oh well. Right, got my special extra crap quality vernier calipers. Now the weird thing about these vernier calipers, especially if you go and watch Julian Illett's video today, he has a carbon fibre version of this, is that whenever you go to use them, the battery is nearly almost dead every time, always dead. It's just such a random design that just seems to suck batteries out. So millimeters. Let's do a 1 millimeter grid. I'm just trying to decide if I want to do this imperial or metric. So let me just measure this. It might be an imperial size. 36.49. Sounds a bit dodgy. It's not even quite 1.5 inches. Yeah, let's keep in metric. We'll worry about the pin spacing afterwards. So grid millimeters. 1.1. That should do. So I've got to just start drawing this T-place for that thing. What I like to do is just draw the first line. Yeah, even if you don't know what it is, it doesn't matter. Just draw the first line. Just go from 0, 0 to x0, and again check my vernier calipers. 36.5. 36.5. Arse biscuits. That's not what I wanted. There we go. Good. So that's our first line. That's the top. Going to get a second line in there. Please feel free to talk among yourselves. I know it's not necessarily the most interesting thing to see somebody doing, but you know, I'm just going to keep battling on. 19.9 mil tall. 19.9. That's such a weird dimension. Another dimension, another dimension, another dimension, another. No, it definitely is though. I can. So I'm going to measure that little sticky out bit in the bottom. That's 3.5 mils. What was my grid spacing actually? I think no, I'm not gonna. Just do it with numbers. Don't mess with it. 3.5. There we go. And then that little. How do you measure that little frickin' thing? looks a bit like a 2.3. Close enough anyway, whatever it is. Cock. 2 point. I'm just going to draw this one in. 2 1/3. That looks about right. There we go. Nice and accurate. So, what we can do, which is quite neat, you can do that cloney thing, so you don't have to keep redrawing it. I mean, how accurate do you really need to be with this? Not very. So I'm pretty much overdoing it. I'm overthinking this, but that's fine. That one should have been just on the line. Oh, look, it's just doing that. There we go. Nice. One last bit. Boom. And the last wire indeed. Get that going. Copy, not write it. Have a nice weekend. Will do. Super Sweet says, I can't either playing Euro Truck driving, so thanks to Swansea while listening to your stream. Oh, right, yeah. That's that game looks really interesting. I kind of like the look of those games, especially like the train simulators as well. So I think that's pretty representative of this. I'm just going to look at the pins now because, again, they've not really been very clear on the where those pins are in conjunction to this module, but there's 3 millimeters between each pin. Does anybody know the inch grid size for that? Or shall I just switch it to, what is the pin header pitch? 2.5 something. Just going to read it off the vernier caliper and switch to inches. Not good at maths. Not good at maths at all. Yeah, 0.1 inch. 2.54. Is that inches, Brian, or is it mils? One-tenth of an inch. Ah, okay. Just looking at that. Does that look about right, though? Just go for it anyway. So we have along the top, well, we've got 1 to 14 here, and somewhere 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then there's going to be a gap. So there's a lot of measurement if you're doing this, messing around. 14.4 mil. Where are we? Let's do this calc. 15.24 minus 14.42.82. So it's saying it wants that to be about well, put that there. 2.53. Yeah, okay. The chat overlay is getting in the way, isn't it? So what can I do with the chat overlay? We can probably make it smaller. Is that even legible? Or make it just disappear altogether. Away with you. It's there, but off the edge of the screen. Let's go. Let's get a bit more room on here. Okay. All right. You totally distracted me now from my my pin placements here. It's going to be a chore though to put that second row up, isn't it? I'm just going to... Maybe we'll just half-arse it. Go, yeah. Good enough for me. Cha-ching. Control right click. Yeah. So I've just got the module looking, just looking at the module, looking down at the module while I'm messing with this. So I'm thinking it's probably about thus. Bang. Good. I feel that we're making progress, slow progress, but relatively steady progress here. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11. Oh, they are actually numbered. Friggin' pretty good. I didn't really have to change the number. Oh well. 15. Hang on a minute. Oh yeah, that is front view. Whew. Almost had kittens there. Right. Bloody thing. 28. 27. 26. 25. 24. 22, 21. This is like why you don't want to pay your design engineers to make libraries, because they're paying all their salary for doing this activity, which doesn't add any value at all. Boom! Good. Good, 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 good. What's that one? That one. Do we want to do that sort of bullshit? Let's get this. Fudge. Eagle, you bastard. Does anybody use Eagle here? Because it has the worst, I want to say, controls known to man. Oh, why would I want to clone just that corner? Bugger. 1, 2. I have to do it again. Look where the cursor is as well compared to the object. 3. My sense of scale isn't quite as good as the datasheets, but I think it's good enough for us. Now, at the end of this, I'm hoping someone will remind me to upload the Backoffice library so you get this. 4, 5, 1. Have I done that right? 6, 7. Yeah, that's pretty much good enough. Bang. And we've got some other random boxes, which I think I can just probably right click. Nice. Boom. I'm probably doing this wrong in that there's probably quicker ways of doing this whole thing, but I never bothered to learn it right. Okay, and then we just got a G2. We're going to shrink down. That's good enough. How's that? Good stuff. Okay, so the next stage is, of course, I don't know if I really want to do this, but might as well then. 1. You bloody thing. This is just a terrible grid. Okay, I think we can go down a 1 mil or something now. 2. Even 1 mil's not good enough, is it? Nothing ever works out. There we go. Sorry, I'm gonna half-ass it now. I can't be bothered. Bang, 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 bang. Good enough, good enough, good enough. Nobody cares once you get it down. So 1. How do I change the text value? 2. So yeah, my plan is now, after this bit's done, is to actually start laying out a board, and I'm really hoping the other components I've got are already present in some sort of library. I think I should just go with my own grid, actually. I think I'm just going to randomly assign myself a grid, and that's going to be my random spacing, and it won't fit any PCB. Ah, fudge. That just annoys me too much now that that one isn't in a in the box, so I shall make that a bit bigger. Last one, the last thing, and that's the label again. LS. Actually, you don't need this, do you? There's some weird shit you should be doing in Eagle, like equals name something. I want to do that. I want to do that something, maybe. Let's see if that works. Doesn't matter, otherwise it'll just come out as name. Good, right, finally, now we get to do the whole device. So LS 207 4M2G. Yes, please. Oh yeah, how do we do this? Nice. New. Yeah. So now we just got to connect the doodads. Shit. Oh, YC1, YA1, YC2, YA2, RC. I'm just going to put my finger near the screen to make sure I don't skip a thing here. 5, RC1, RA1, RC2, RA2, GC1, green 1, cathode 1. Bang, 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 bang. I'm getting confused now myself. Right, and then the G2 cathode 1. Right, that should be 14. Yeah. So far, so good. And then pin 15, F. FA. Fa. AA. 7C. Yep. BA. 6C. 6C. DA. 5C. 4C, 3C, CA, 2C, GA, 1C, EA. Whew! Yeah, total confusion on my part, but damn it, we got there. Damn it, we got there. I feel relief, actually. I feel relief. Now, 7. Let's have a look here. I just want to do our sanity check so we keep an idea of what the A, B, C, Ds and all of that thing means. I like the idea maybe of putting it somewhere. On maybe this. Yeah, I like that. I don't know if it's feasible or not, but I'm just going to try. Yeah, I have my coffee and I have my cake tin with some cupcakes in it. But I feel I need to. I got to just get this last bit done because then that whole package is kind of complete. And then I will have that. That doesn't look good. Shit. Let's get this grid spacing something a bit more easy to work with, not in fucking inches. Okay. I do apologise for my language as well. Actually, I feel it's I'm very rude, being very rude. And I understand we've got a lot of guests from overseas on the live stream right now, and I am setting a very bad example. Yeah, I'll have a mouthful of pins. Oh, maybe if we can make this a bit more teeny tiny. Ah, they're all A's. Suck it, bitch. A's all the way down. Hey, Amsterdam. I've been to various countries and I can't remember. I want to say Holland. Am I right? A D. No, that's a D. Damn it. That's a D. Should be a D. Just make it a D. Yes, that's a D. G. E. F. A, B, there's no friggin' C. C. Ah, right. There we go. Holland. Correct. Boom. What I'm going to do is I'm going to bring the chat thing on. Oh, no, don't do that. I'm disrupting the whole back office flow there. Sorry, I'm messing with the actual... whatever we call it, OBS software. I'm just going to put that there, and then I'm going to have my bit of cupcake, you see. So I'm just going to put that on there and just read the messages, read off the messages there. Right. So let's review what we've done so far. So we've measured the component. Hopefully made something that resembles its actual footprint and pinout. I may or may not be right on that. And I'm going to be eating this this cupcake. So I'm just going to. I should scroll back and review some of your comments. And I think I can actually pop the chat out. Look, I can just pop it out like that. That way I can just get rid of that one, and we can just see that one. So I'm going to have a little review. We'll start up from here then. So we'll start with Riley King. Have to run for a coffee. Need it. Need it causes of last night's casing. Don't know what that means, but yep, coffee's good. Then Brian helping me out on our pin pitch. Philo, again, 100 mil. Why Imperial has to have something called a mil when that's clearly a metric thing to confuse us? I don't know. Kevin deserves copper and a biscuit. I'm doing that right now, sort of. Cupcakes go. I might have 2 cupcakes actually. Oh, Mark. Hello, sir. Oh. Now, everybody who's watching, Mark is the kind gentleman who's donated to the channel that Steel Battalion joystick to tear down. Isn't that right, Mr. Wallace? I'm allowed totally to break that apart, even though it's the rare one with the elusive blue buttons, I think. But Brian, isn't it more interesting to see how it works? I'm just going to jam the whole half of this cupcake in right. Well, get rid of my crumbs and I'll continue. Let's do this thing. I don't know what's so special about it. People seem to go mental at the thought of tearing those down, but surely it's just, you know, it's just a joystick at the end of the day. Right, we have our booby pinout ish there. Oh, I'm going to discover how to do this at some point. Or actually, I'm going to post the library to the GitHub. And one of you could do that for me in a better way. Is I want to do a booby header as a component in the library. So I can just keep putting that down rather than mess around with it every time. Pardon me. Looking here, this friggin' version of Eagle. So if you go from version 5 of Eagle to version 7, they changed all the bloody icons. So I've got no idea. I just want to draw a wire. Which one's a friggin' wire? That one? Yeah. Why do they have to change everything? Actually, we'll just leave the pinouts for now. We don't need to worry about that. So let's maybe our booby library, our back office library is probably already in play. Look, it's taking its time to load it up though. What did we call that thing? LS-207. Okay. There we go. Back office library. The back office library, it's there. Yeah, Theo, it doesn't make yeah, exactly. Downloaded content. Yeah, as you say that's I am quite anti paying for this every month when I had a regular license on the previous version. I don't really want to have to do that. So we're going to use one of those. And I've got another chip here, which is a MC14511 BCP. And oh, come on. Don't make me have to friggin' bastards. Right, I have to bring up a data sheet now just to see if it's any way near similar to one of those. 511 BCP. If you're playing at home, I'll paste this into the text. That's a 1. Blah, 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 blah. I wonder if our A, B, C, D, F, G stuff all matches as well, actually. While we're here. Yeah, that's good. We'll shut down that library view now. Okay. Where's the pinout? Have I passed it? Here we go. So I'm trying to look between these two things here. I might as well just paste them down. Actually, interesting enough, if you look at the footprint, they're bloody useless for what I want. Yeah, I don't think the ozone generator's on enough. try that again. 14511. Shit. I don't know if you can do multi-part searches or wildcards in Eagle. Just search manually, I guess. So those are wrong anyway in terms of the package. Wrong in terms of the package. I'm not really winning today at all. So the next thing to do is see if somebody's already done this. No! Oh, you shit. Get away. I saw it there briefly. Download! Ha! Beat you, you bastard. Right, so you've got this library. I've got it in another window here. I'm just going to drag it across if I can. Yeah, it is an LBR file, so let's cut it. I'm going to paste it into the standard Backoffice show project folder. Wherever the frig I put that. Yeah, there we go. Use. Right, 14511. Oh, you shitting me? Oh, you shitting me, boy? On semiconductor. Just seeing how many parts are in here. It looks like there's enough that you don't want to manually search them. Yeah. Neither of these sound particularly near, do they? Am I going to have to bloody just do this part myself? I think I'm going to have to do that as well. How close is it? VDD is the same. Yeah, it's already not looking good. Pin 3's a latch. Yep, totally bullshit. More bloody bullshittery. Fuck sticks. This is going to be so fascinating to watch the pain. Oh, is there a seed studio library? That's interesting. Anyway, am I losing my mind? Where's my library gone? Is this like a different version of Eagle that I started? I think I was actually editing. I was editing the library in a different bloody version. That's amazing. How does that even happen? Got to add that path. Right. There we go. That was weird. That was super weird. Right. Okay. Let's get this MC blah 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 blah. Now, if anybody wants to play along at home, in fact, I'll just check the next part I want just to make sure it's got one, because if it hasn't, one of you might actually be able to, you know, see if there's. Why do I have to save it? Yeah, whatever. Come on. I just need a decade counter. Something, whatever you think, is a nice little, simple, reliable decade counter. Oh, I meant they're just giving me only surface mount. What is going on? All of these seem to be SO16, weirdly enough. I mean, I'm not that bothered, but it'd be nice if they just had a... Oh, they have the deal. There we go. Right, I'm just going to chuck on this for now. I think it might do. If you know what a 4026N is and you know what I'm trying to do, or you can have a guess what I'm trying to do with it, yeah, have a think about that. In the meantime, let's just get this bastard done. What does that mean? Fucking Windows. Right. Got ya. Can I have my library back, please? Right. That looks about right. How many pins have we got? 16. Let me try to actually do them in the right order now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Good. That seems about right. Rattle through those. B. C. LT, guessing that's the latch. I, Lee, D, A, VSS. Sorry, let's just have a quick look here. Anything interesting? No, that's fine. Chat among yourselves. This is going to take a while. VDD. Right, F. Lowercase. I don't think you can do a lowercase in Eagle, can you? A. Bollocks. Let me try again. Definitely don't seem to be getting to do lowercase. So now I'll have to check that. Eagle CAD. Lowercase in Eagle CAD. Oh, fuck it. SF. SG. Segment F. Segment G. Segment A. Segment B. Segment C. Segment D. And segment E. Oh, I think it's that. I think it's that. I don't know. Right. Save that. In case it goes Tonto. MC14511B. New package. Oh. There must be a deal. I don't need to create this package at all. How'd you delete it? Oh well. Doesn't matter. MC14511B. Yeah, let's create a new device instead of crapping over that one. Oh, you are killing me. That is absolutely shitty. I don't want to have to do a new package for a standard footprint. There must be a way. Oh, it's just torturous. Eagle was pretty kind of, I like it, and but it's got these idiosyncrasies, right? Navigate to the library part package symbol you want in the control panel. Right click part, copy to library. Bye. Standard libraries, footprints, where the hell is it going to be in? Let's try that. No. That should do. Dill 16. There we go. Got that package. Right, so that chap reckoned there was a copy to library function somewhere. Oh, I give up with this piece of shit, really. Duplicate? I don't want that, do I? No. What's that one? Open a file. So dry. What was that thing I had typed in? Maybe I should just keep the screen open instead of shutting it down every time. Open desktop nav part panel. Right click the part. Copy to library. There's no fucking copy to library there at all. Damn it. Can you just copy it? Copy paste? Let's try copy paste. Oh, but it's a clone. It doesn't even have a fucking copy, does it? You know what I'm gonna do, guys? You're gonna love my strategy here. I'm gonna use snipping tool to do that, to copy a picture of it, and then I'm gonna go back to the control panel. I'm gonna go open up my library, and I want to make a new package that I'm going to call dill 16. And I'm just going to copy that. Just literally draw it the same way. But I don't want to quite do that because I want to make sure the pins are in the right order. So I want 1, 2, 3, 4, 5, 6, 7, 8. And then they've got a 1, 2, 3, 4, 5, 6, 7 things. 1, 2, 3, 4, 5, 6, 7. 3, 4. It's looking pretty bloody good. That's good enough for me. That will do nicely, pig. Bang. Finally. Let's do this. B, C, L, T, B, I, L, E, D, A, V, S, S, E, D, C, B, A, G, F, Z. Right, fudging bollocks. Okay, so the next step is to add that that bloody part. MC14511B. Hooray! I like how it's not doing the name thing because I did that wrong. That's fine. The mysterious part of no name. Let's get that down there somewhere. I like how I took care of numbering those pins nicely as well. Left them as defaults. So the idea is that's going to be a latching driver, and I didn't print out the data sheet, so probably ought to have a look. So there's our values there. Start with the obvious stuff. Move our display up a bit. Kind of like to see them on the screen at the same time so we can get that in there. There we go. Now, I'd never really learnt it, but I don't know if there's... I suspect there could be a quicker way of doing what I'm doing, where you can just do them all at once. But I don't know it. But I'm pretty sure we're going to need a lot of these. In fact, the ones I'm bloody doing now are the ones that we want to do at the end. So these are the ones we want to focus on. Okay, so these are common cathodes, are they? Yeah. Now the thing is, these are common cathodes, but they're kind of I was looking originally for designing this circuit for individual common cathode displays, where using this BCD chip, you'd have a BCD chip with each display, and you would be able to, say, multiplex them with a decade counter. So the booby board would just switch through each segment and just update them with what it wants. But because this one's kind of on a matrix display, I'm wondering if it's even feasible now, if this has totally scuppered my plan, really. So this module apparently is from a old mobile phone or something from back in the day. But just looking at it here, it does look like it's a matrix thing, so it probably won't necessarily work with a BCD. Or will it? Or will it? Or will it? Well, it clearly will. But I'm guessing we'll have to multiplex the bit of timing work needed here, because you're going to have to multiplex the actual segments, because it's not going to have a hold on there. So let's just label them up. Let's just pretend we were going to do it in the usual way, and then just take it from there. Oh, that's my pin. Oh, look at that. When I made the part, I must have made the pin spacing. No, that looks pretty regular pin spacing, is it? How come you can get two labels there side by side, but here? Arseholes. It's not my day. It's not my day. Let's just go old school. So I'm just naming the nets. I'm not even sure this circuit will work now as I sort of intended. I'm pretty sure it won't. We can still use the BCD though to just generate the yeah, Eagle does suck. Yeah, sorry, I'm a bit I'm because I'm just making this circuit live. I'm you know, in my mind, it's thrown me because of this LED display is not the original style that I was going to use, and this aspect of it having that kind of matrix. So I don't know if any of you watching actually get it. If you do get it, please feel free to shout out in the comments here. But as I said, my original intention was to use individual 7-segment modules. I've got some with two panels, 7 segments in one. So to make a clock, for example, you could use just 2 of those butted up together. But I'm trying to think, how do we handle the switching here? Because anyway, I'm just overthinking it. That's the problem. Can we name the net with this? Yeah. So let's see then. SF. Might not hurt to have a look at the data sheet just to see how they're wiring it up. So we're just doing it like this with a common cathode here. So they're wiring up with a resistor, which is fine. We can do that. So we just bring that out like so. Find a suitable resistor. Yeah. Let's find a suitable footprint here. Don't people like through-hole stuff anymore? That'll do. Bang, 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 bang. And look, don't you just love this now? So you got to go in there. Don't let that get gotcha. Get rid of that bit of wire between the two, or you will be screwed. So I know there's some talk there on the different CAD packages, but if you actually think CAD, I want to call it, is any good. I'm willing to try it. Let's do a 220, shall we? Oh, it's going to get confusing with these labels. But I'm willing to try it. If it's easier to use, better to use than Eagle, can do all the same sort of things, I'd certainly give it a go. I'm not going to bother smashing that yet. Wasting time. So, why did I name that ASEG? FSEG. ASEG. BSEG. DSEG. Easy EDA. DVDA. CSEG. GSEG. One, two, three, 4, 5, 6, 7. That's certainly the right amount. FSEG, GSEG, ASEG, BSEG, CSEG, DSEG, ESEG. Woohoo! I just want to see what it's starting to look like. Oh, look at that! It's starting to look real. Oh, look where I put the center point of that. Okay. Boom! That's going to be sweet. Piss off. Right. VDD, I can do that one. That one doesn't need the resistor. That would have been a mistake. Yeah. That would have been a big mistake. Good. Although I don't call it VDD, I'm calling it 5V. Easy EDA. I'm still seeing that. Every time I look at the chat, there's that hint of using a different package that might be better. Right. I think that's kind of where we're getting at. Just got to see what all these other bloody pins on that chip mean. Oh, okay. So capital D, A, B, and C are our data lines. I should have put those together. I should have read the data sheet first and put those together in the CAD, but why fully? Well, if you're going, there's no point to arsing it fully when you can half arse it. So, I'm just trying to see if it's big endian or little endian. So A is the most significant bit here. So I'm just going to call it D1, D2, D. Well, hang on, why am I doing that? Just call it what it is. Fuck's sake. I was just trying to add an extra layer of total confusion, and I've done that thing where it's screwed up now. So you've got to kill the wire because it's joined the nets forever, irreversibly, incorrectly. Good. That's pretty sweet. Yeah, just put them on the wrong pins. And we've got some GPIO. We'll do that afterwards. We don't need that right now. So LT, what's an LT? Oh, I see. This truth table is really, really telling you everything we need to do. No, I would kind of like to know what LE actually means. Isn't it just going to tell you? No. Like you've got to friggin' read it now. 216 FETs. It's a lot of complexity. Yeah, it could be a latch. You know what this has? It has a weird thing, I think, where it can possibly turn all the outputs on. There's no decimal point on this, actually, is there? I suppose you don't need one. So if you want... Oh, that's enable, right? BI is just an enable. So if it's 0, it's blank. But it looks like you can make the screen blank through a different combination. So BI, I'm going to pull it up to 5 volts. If I may be so bold. Boom. So, you know, I'm just studying. I'm quiet because I'm studying. LT. I think that LT must be a latch, right? Because look, LE doesn't seem to do anything, does it? Depends on the BCD code previously applied when LE was equal 0. Oh, LE is the latch. So you were right. Yeah, you did say LE was the latch, to be fair. Mr. Verdi Rodriguez Diamond. I want to get that right. I've got this habit where I just see people's names, but I don't, say them in my head. It's a bit like reading. LT. So LT of a 0 displays a screen check. That's why it displays the full 8. That's the first line there, LT0. So pretty much LT we can bring up to 5 volts too. Permanent like. But I like once you get these done, these are like your reference designs for the future. You just cut and paste your same things forever and ever. I don't know if you're similar to me, but that's what I seemingly end up doing. And then I'll probably make this look a bit prettier, so I can just again cut and paste it. Good. So I think we're almost there. VSS. Let's give that something. We're going to set that to ground. Yeah, there's a timing diagram, but I wouldn't worry about that. Let's not worry about that sort of detail. That's all hooked up. That's thing. So now we have the cathodes to multiplex, but we can't do it directly, can we? Because we'll need something that can sync that. We'll have to have some trannies in here. Possibly. Now let's bring this header up. Fucking Eagle. Right. Can actually just get a look at all of this. Got my booby board in front of me. Let's just add any spare I/O pins. There's not many on this thing. I think this is why people just go to LCD screens if they can. RC2 all the way down to RA0. So then 1, 2, 3. We do have a spare one here that we can use. Pin 9 we can possibly use. I'll give it a little bit there. And we should get our ground in. Like that. RA3 and ground. So technically you're going to need, if you're going to use just this one thing, you're going to need 5 pins. 1, 2, 3, 4, 5 just off the bat, which leaves you with 4 pins to multiplex, to run a multiplexer for the remaining segments. So I think we still will be using a decade counter, but we'll just be using it in reverse then. So we're just using one BCD chip and a multiplexer rather than a multiplexer and like 8 BCD chips. Booby board. The name of the booby board comes from the blue-footed booby, and that's why a booby board is that kind of blue footprint. And there is a little mascot somewhere of a bird and the whole thing. It's a bit like Linux's Tux, the bird. I think it was designed by the same kind of person. Decade counter. I'm really confused here. It says decade counter divider, 7 seg outputs. What does that mean? Why so specifically 7 seg? 4033N. Let's see if there's a data sheet for a 4033 there. Maybe. That'll do. Just install all the viruses. Get that over there. Right. Does anybody know? I'm gonna think I need a way of syncing all of this current. Would you just use transistors or Summit like, or is there some one of these decade counters with a decent enough? Yeah, you are talking up to 7 LEDs on each hit here. Where were we? Clock inhibit, ripple blanking. These look so simple when you buy those kits from China that seem to use them. Right. Clock. Seven segment display devices. So they're actually almost. Oh, that is weird though. What are these things they're driving? Incandescent bulbs. Tube requirements. What the frig are they driving? Is that for a Nixie or something? No. Tell you what, let me just grab a kit. Got 1,000,001 of these kits from China that we've put together that use these decade counters, and I just want to have a quick look at their circuit diagram. So they look like this. So this one's using a 4017 Let's see if we got one of those. 4017, I see. It's a bit of a shame because it looks like that would have been a good one. Let's have a look at the datasheet for a 4017. Clavis, you clart. Yeah, there you go. That looks nice and simple. You need hardly anything on that one. But frigging Eagle Library probably doesn't have it. 4017. Star 4017. Star 4017 star. Ah. Oh. I'm not even going to look for the earlier parts that I tried to find in this because maybe I needed the bloody wildcards. Right. Let's plop it here. Ploppy, son of Ploppy. So I'm just going to pretend for one moment. Let's see. So the decade counters seem to be driving the, I want to say, anodes of the LED. So that's fine. That can go straight into the inputs of a tranny. What's a good transistor? A good solid, we need a good solid basic transistor that doesn't come in any of those footprints. Surface mount. No. Oh, Darlington. Yes. All right, I think this will do. We're going to use these. And we need one for each. We need 7 of those. I'm thinking, what's a good way? A BC247. Okay. No 247, I'm afraid. Next. How about 237 though? I think that was pretty close, right? 237, it's only one number different. So I'm going to sketch up kind of what I think, and if it's bullshit, I want you to call it out. Bullshit! Why am I beeping? Why am I beeping? Oh yeah, okay. I want to go... I need another resistor, don't I? Steal one. Boosh. Did it actually connect it? Yes, it did. What is that corruption? Oh, look, it's actually got a writing on it. Teeny tiny writing. Right, so if I call... Let's get some labels just on these. Typo 547. Okay. There's a swap device function somewhere. Swap equivalent, swap parts of a different device. BC 547. Boosh. Bang. It's that easy. It was that easy. Thank you, Eagle. You're such a great piece of software. Output 0. Okay. Anybody watching, does that make any sort of sense right now? any sort of sense. Hang on a minute, that's a cathode. Does that work? How do I do that? Where do I hook this bastard up? I don't think I can do this, can I? Or yes, I can. I'm going to just sip on coffee while you get a chance for the buffer to catch up and ponder that for me. I am looking. I'm going to be putting the live chat thing. Whoever answers this question will win 50% off a Backoffice box. How about that? Backoffice box. I'll give you the code to win. To win it half price, 50% off. If Q0 is pulled high, will it do what I want to do via this transistor and thus activate the segment 1 LED display? And actually, while you're thinking that, I'm going to just crack on our clock, our enable, and our res. What is res? Reset. Well, the anodes are all connected up to the BCD latch. I think though we're going to need, if we're going to do it right, we probably want these. So I'm just marking these up here because we want these controllable by the pick, so it can pick on the booby board, so it can actually be in total control of what goes on this bad boy, because it wants to be able to reset it when it's not picking. Right, okay, let's have a read. Sorry guys, just sort of catching up. BCD, current limiting resistor, LED, yep. Transistor, ground. Okay, let's I'll work on Verdi's solution first. BCD is here. Current limiting resistor, yes. The LED, yes, it's going through the ASEG or whatever. The transistor and then ground. Yeah, well that's. I think you're both saying the same things here. Am I right? Segment cathode. Resistor, transistor. Does it need another resistor? So I think what the guys are saying, it wants a resistor between here, but does it need it? You've got a resistor here on each of the actual you've got a resistor on each of the actual LEDs and the display itself, so I don't think you should need a resistor on the cathode, but I could be and probably am wrong. The LED's cathode is pulled low by either the BCD decoder or the transistor. But the BCD is connected to all the anodes. Where does the LED get pulled high? Well, the BCD should be pulling high or low. So I tell you what we need. Let's get a bit of MS Paint going on here. Oh, I hate MS Paint now. It used to be better before. Right. So if that is the BCD, before I do that, you could be absolutely right on the BCD. Let's just see what is the BCD. We might need to invert its output, right? What I forgot the part number of the BCD then. MC14511 BCP. It probably is open somewhere actually on my desktop, but it doesn't matter. Yeah. Now's a good time to probably just have a little think about all of these components. Forget about the latchy thing right now. So the BCD are common cathode devices. So if you want a 0, they're all high. Yeah, sorry, Verdi. Yeah, the whole transistor thing, that's just for working its way through each of the characters here. Yeah. Yeah, always pick Kathy over Annie unless you're doing a direct drive from your microcontroller. Then that's pretty good because your microcontrollers can sink more current than they can source. I might be just losing my mind here. Hang on. Right, let's all agree. We all agree it's common cathode. Okay, fine. Booyah, common cathode. Now, what does this look like it likes? If you want to make a 0, it's pulling them all high. So this looks like it's for a common... Yeah, this is for a common cathode, right? Yes, it is. This is correct. So the LS247, that's acting like a switch. So we want to go boom, boom, boom. Then that's going to be in the transistor like that. But we've got a resistor here too. Okay. So when the BCD shuts it, we've got current coming as far as here. We've got potential coming as far as here. And then once the transistor is pulled up, then that will sink it to ground. That's my logics. No, I was gonna have a transistor for each one. So I was gonna have 4, 5, 6, 7 transistors. That was my idea. It's gonna have 7 transistors. Yes, the trannies are chip select, absolutely. And it's driven by this 4017 decade counter, which is acting as a multiplexer. I think you're getting it. I think you're getting. Well, you're trying to get what I was thinking. I might be wrong, but that's my logic. Let me just draw out the rest of the pins and stuff, just so we're not hanging there. Exactly. One transistor for each digit, not for each segment. Correct. The segments are being controlled by the BCD. 0, 1, 2, 3, 4, 5. I'll just get this, because this probably would have been a bit more clearer if I had bothered to finish this. Now, whether or not I'm right still is not totally crystal clear. I could be wrong. So if you really disagree, I will respect your view on that. So that I think it'll work. So if I'm going to delete my paint thing, but yeah, I think that's what's going on. And I want to work through it just real quick. If we look at a 0, yeah, 0 is putting everything high apart from the middle bar, which is fine. So these would be all high. So all of these segments would be live and firing away, and then whichever one we ground here, whichever cathode we ground, will illuminate. So if we're on say 0, we're going to say LED 0, segment 0. As soon as we pull segment 0 down, which is 1 cathode, I've got a bit of a mismatch on the numbering here, then that all those 6 segments that are live here will illuminate. So I think that will work. I do think that will work. So let me just go through then and add that up, those labels to things. If you remember on our last live stream, Julian did join it. I kind of wish he joined this one because he probably would be able to check the workings here. Seven cathode. Right. So there was a prize to be given, by the way. I did say that, didn't I? But you might have to decide among yourselves who you think won it. I'm going to go for a 1K here. I'm just going to tidy up this pattern because I'm going to cut and paste this. If I tidy it up once, that might be all I'll need to do. Could make it quite compact, basically. I think that's okay. Let's go for that. 1, 2. I thought it used to repeat that operation. One more lot. Again, maybe a better way of doing this. Now, there's a danger here. Let's just see this. Sometimes it can screw up. So if I have that as 1 cathode and now I want this on 2, it might change all the nets. Let me just check that. No, that seems okay. 1, 2, 3, 4. Yeah, wait, Verdi, where are you based? I bet he's based the furthest away. It'll be like the hugest PMP. 7. Right, output 0, output 1. I can never remember either, but I'm thinking the cathode's the negative. That beeping, I don't know if you hear that beeping, that's a motion detecting alarm thing I've got. And it's getting a lot of false positives here. Unless there's a burglar running around that I don't notice. Oh, it's a spider on the camera. Oh, Canada. That's okay. I can post to oh, Canada. No, don't worry about the postage. I'm going to give you the code. The fortunately for me, the buyer pays the P&P, but you get 50% off the product. So I don't know. You can, if you're really that bothered. I tell you what, I'll give you the code, and then you can give the code to somebody else if you so wish. Strangely enough, I'm just typing in a thing. I managed to forget my own website URL. Would you believe it? I kind of think though I'm feeling good about that design. You know, I feel I probably won't rush out and just get the PCB made before trying it. But I'll certainly. Okay, Verdi, here it is. Don't show anybody else. Right. So, okay, where was I? I just saw, let's see, this pin headers. Right, so I think that's 1, 2, 3, 4, 5, 6, 7. We've got our grounds there. We've got our 1, 2, all our outputs. There's the website. Fight! Fight to the death! You know what you could do? I'm just thinking, if you could do something that when you get to... I'm going to turn off that bloody beeping. Hang on. Oh, Canada. Right. Right. I'm just trying to think what happens when you get past output 6. You could do an automatic reset. But I think what I'd probably do is when the pick is ready, when the booby board is ready to display, go back to the first digit. It will probably just reset this and then go around again. The nasty thing, the real shame about this is we're not getting to use the latch on the BCD at all. We don't need it on this. We're just using it as a decoder. We're not using any of its latching capability, which kind of sucks because you can't have a hold. So we're going to be constantly running the bus basically, and that means you might get a flicker anyway. You'll definitely probably get a flicker, but it also means if your booby board is busy, if you want it to do some other things, you'll have to make sure that the service routine for the 7-segment screen is interrupt based, so at least the timing on all of the display update. But saying that, you know, I don't know, I can't remember what the pick's running at on the booby board by default. It's pretty fast. I don't know, like 4 megs, maybe 8 megs. And if we really wanted to, but we might lose some pins doing it, you could enable the 20 meg crystal on there. It'll be running faster than a human will detect the flicker. But okay, right. Let's crack on with this then. So I don't know about if I want to leave these pins floating. I'll probably will for now. Let's see. Let's get ready to rumble. So we've got these 1, 2, 3, 4, 5 pins from there to deal with, and we've got 3 pins from here. So those 3 pins look like a lovely match there. So we're going to go with a CLK. Oh, hang on. Gotcha. A gotcha. Danger, danger, Will Robinson. If I recall, RA3, pin RA3, let's just kill that mother Hubbard. Boom! RA3 is the memory clear pin, programming pin on a PIC, which means it cannot be used as an output. That would have screwed us up big style if we'd wired that thing down. So that's fine. Bash. Bosh. A. Oh, we've already done A. Go. B. C. Oh, we're running out of pins. Let's get ready to grumble. PLL, phase locked loop. I don't know, Verdi, if they do or not. I have to check your board out. However, today I just got the pictures of the boards that are in transit to me of the Booby Cortex, which is an ST ARM Cortex board. So Booby Cortex will do the PLL and PWM and I2C and SPI and everything else. But I normally like to bit bash those on a Booby board, a normal Booby board. But yeah. Now, we've got these other things here. If we look on the screen, if you look there, we almost finished actually, but look, you see on the bottom there, there's a bunch of LEDs here, and those have 2. So there's 1, 2, 3, 4, 5, 6, 7 LEDs in that. So we do have another 7 LEDs that we could kind of hook up. So I'm just seeing here. We've got 4. We've got 4 thangs here. We could just hook them up for one more. How about that? Let's do that. Let's do that. We'll do one for driving the actual last bunch of shizzles, to use the technical term. The last bunch of shizzles. Bang. And we'll call that 8 cathode. We'll pretend that's like an 8th, the 8th hobbit. Let's get our wire down. Let's get our wire on. Hang on. What the frig is that? I've been using that. Net. Wire. What's the difference? Okay. Hopefully nothing. Apart from maybe it puts that green blob on. Output number 7. We're pretty much there now. 8 cathode. So we got a lot of 8 cathodes going to go on. One, 2, 3, 4, 5, 6, 7. Phew! I was worried there. Thought, oh, if there's more, it's going to be a bit more complicated for me, but that's fine. So, okay, 8. Hi, Riley. How far, in terms of the explanation about the theory, what level do you want me to come in at that? And bearing in mind, I've only kind of just taught myself electronics, and I have a very, very poor understanding of it. I can tell you my theory, but basically the idea is, you've got this display right here, and it's got 7 segments and this bunch of multicolor LEDs on the bottom. And the theory is I'm going to drive them all using this handful of components to make a nice little PCB that was part of a challenge box in the Backoffice kind of mystery box that went out. and I felt obligated that I ought to get it working myself, and this is my solution. So the idea is that this chip here, the LS2074 chip, is acting as a multiplexer for the 7 segments, and the transistor at the bottom, the transistors are being driven by a decade counter, which is that chip on the left, and that's multiplexing the actual screens, as it were. A, B, C, D, D seg. Yeah, exactly. B, C, D, E seg. So does that explain it enough? Or do you need more explanation? Look at that, guys. Everything is connected. Tilo, concerns regarding persistence of view. I mean, no, we should be able to multiplex really shit fast, right? If it's by default running at 4 megs or 8 megs, I can't remember what Booby Board runs at. I don't think there's going to be an issue on that. We're not using the standard Booby Board firmware for this. That would be mental. We're going to be, I'll probably write a real firmware for it. I mean, in the original design, of course, I wasn't intending to use these screens in that way. So if you can probably test it using the standard Booby Board firmware, but I think it's going to be real. It's going to be real slow. I mean, I think you're just going to see. What will you see? I mean, you're just going to see the characters moving left to right. It's going to be that slow. You won't be able to use a standard Booby Board firmware, I think, on this, not on this panel. So this would be an advanced challenge for people who've gone out and also own these PicKit 3 programmers. And interestingly enough, I've got 2 PicKit 3s here to show you. Okay. This one is the Chinese clone. You can see it doesn't say microchip, but I've tested them all out. They actually work exactly the same way. So for just a few £7 for the programmer, you can just reprogram the firmwares for these. Yeah, exactly. So Tilo, absolutely. And the reason you got away with that is because unlike this one has all of the segments each bloody joined together. So if you can't probably see that, I don't have my microscope set up, but yeah, through PicKit 3.5. So yeah, so all the A's are connected, all the B's are connected, all the C's. So that's why we can't use the BCD. Otherwise, I would have just used 8 BCD chips. That's my intention totally, and then you'd have been able to drive that off a regular Booby Board. But I think I will do a design. Basically an upgrade to this one, because I think people would like to be able to do that with a Booby Board, and I want to. My next project, by the way, if it's of some use, I'm going to be driving a 3-segment display, and we're going to make a voltage divider so we can turn it into a multimeter, say up to 35 volts or something. And not only that, because it'll have the USB, it'll be like a data logging multimeter, so you can use it as a bench meter and also log to your PC, so you can do some logging over time, that would be quite useful, because that would be normally quite an expensive piece of equipment. So I'm just going to give one last check through here. It looks like everything's connected. What I'm noticing though, doesn't this 401N thing here need power? What's CO? Oh, what is that? Microsoft, you bastards. Woohoo! Thank gosh for that. Right. Where did you go, my friends? So what is the CO? I just want to check here because I don't see where's the power go for these things. Ground is pin 8 on that one. Where's our drawing on? I think Microsoft screwed up the layout of all my windows when that disappeared everything. Yeah, you see there's something odd going on here. So that's a 4017. Q0. I think I'm looking at the wrong one or something. Q0 to 9. CP1. What the frig am I looking at here? 4017N. Possibly just looking at the wrong part here. Yes, I have programmed it. Oh, you mean reprogrammed it from Linux? No, I've never really managed to get a good microchip Linux toolchain built. I mean, if you have, I'd be interested to know that. But why does this pin out here, Tilo, doesn't have a pin 16? Look. What's going on there then? There's probably no pin 16. What was that? Someone's made a circuit with one. Let's see what they've done. See, they haven't done anything with CO. Well, look, yeah, you can see what they've done with this module. They've used Q0 hanging anyway, floating, and they've done something with Q9 via a transistor. Clock. The enable is brought to ground. That's crazy. That's some crazy. Look at this. Oh, you bastard, Eagle. Why would you ever want it like that? Okay. It seems we've got 2 of these somehow. Have we got 2 of these? Pretty sure we don't. Ah! Don't want that. Ooh, nice save. Right. Okay, well that might be something we have to check later. Oh, it's just put everything vertically. I'm hello, Mr. Pidgeted 999999999. It's Dr. A, I'll have you know. But yeah, I'm building as part of the Backoffice box board, Backoffice box kit. There were as this mystery LED module. Fudging bastards! And I basically set it as a challenge, and I figure it's to be only fair that I complete the challenge myself. and this is what I'm doing. And this is I wanted to do it so that you could drive it from everything in the box. So you've got a booby board in the box, so it has to be driven in that way. Although admittedly now we've talking that the standard firmware probably won't be good enough, but maybe someone can magic it. And that's what this is. Oh. And I'm regretting instantly using Eagle 7 because it's not the one I pay for. What? And it's got some PCB size restrictions on it. So I will have to pay for one at some point. First things first though, let me just clean this up because we've got some old footprint there. Right, there we go. At least now they're actually laying it out. Oh, is there common net names built into the symbol? Well, the part in question was this 407N. So it looks like we've got 1, 2, 3, 4, 5, 6, 8, 9, so 10. We've only got 10, 13, 14, and 15 connected. That's okay, I forgive you. Oh, for fudge. Not that it really benefits me, because I wasn't a doctor in friggin' electronics. Right, good. Now we're cooking. Oh, what is the board limitation area though? It's like, oh, we can go that high. Oh, I see what you mean. So Brian, yeah, I see what you're saying. You're saying like if you name them VSS, VDD, VBBB, it might just work like magic. I'm hoping so. I'll get round to that in a sec though. Let's just see if we can actually... I don't even know if I can fit this on my El Cheapo. Does anybody know if you can actually export Eagle stuff to the CAD? Because that might have to happen. Because it'll just be as easy. I'm not going to be able to backport it to the earlier version of Eagle anyway. So it's like, well, if I'm going to have to do any porting, I'm going to go onward and upward and just keep going forward with this. Unless anyone at Autodesk is listening and they were considering sponsoring the Backoffice with a license, indefinite monthly subscription for their marvelous package Eagle. Right, so the reason we can't lay out some of this stuff though is because it doesn't let you put anything to the left of that 0, 0 point. I know that much. Shit. Or too much to the right of some mysterious thing, which I think we're already at. I like that challenge though of not knowing how big your board is, but we got to make it fit somehow. When you say it's not terribly pretty, do you mean pretty in terms of how it looks, or just in the process itself? I think we can do this. I think it's all right. I think we got enough. Although, admittedly, we have a bunch of lines on this bad boy that we don't know how to route yet. My Toomba. I'm just thinking out aloud here. I'm laying out aloud. I can't even just park it somewhere. Okay, let's just move those around. Okay. I think we got something here. We got something here. Don't want to be too close there. I'm just going to line up the resistors kind of just more or less with the pins that they're going to be sitting next to. It's a beautiful work of art. Oh, I might just leave them like that. I think that's fine. 1, 2, 3, 4, 5, 6, 7. I guess that's it. That's all of those. Boom, shakalaka laka laka boom. That is looking get in there. Spludge that one in. It designs itself, this board. You know what, that it kind of does. Where would that one go? Yeah. That's looking like a pretty good approximation to a layout. I think I'm going to flip that. Can I? Not worried about that right now. Just think if we can get some sort of symmetry would be nice. Come on. That one should slip in there. It's looking a bit tidier now anyway, isn't it? It's not amazing, but it's not totally horrible. Oh, where did you come from? That looks like a lot of resistors to sort of have to jam in that area. Save that. Bang. No. That one. I'm thinking I can do better on this. It's an awfully wide PCB. Let me just drink my dregs. Shall we have a bit of fun and just try to route it? Yeah. Don't answer it. It's a trap. Bang. Look at that bad boy. Please go away. Leave me alone. Ha! We're getting a 94% already off the bat. I know. Is that you? Yeah, hello. 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 See, it's just one of those bloody crank calls. Not really. Not crank call. Just one of the people trying to sell you something. Right, so, well, I think I'm done, aren't I? Job's a good one as far as I'm concerned. If anybody uses Eagle, what I could do for a bit of fun, I could upload this as is right now. We could have a board layout competition. See who can do a better design than me. If I had your number, yeah. Okay, I'll tell you what. I'm gonna. We need something on speakerphone. I tell you what. I'm gonna give Tilo my number right now, and I'm gonna get him to call a different number that has a speakerphone, and I challenge him to. You can Skype me on that one. That's my special reserved back office number that not anybody has. You're the only person, Tilo, that actually has that number. It's like I don't use it, but it is there, and it's that phone that you might see in the back. So if you call me, I'm going to put you on speakerphone, and everybody can hear you if you've got the cojones to do it, right? And you don't want to cheap out on calling a UK number. I don't know. There's something unpleasant, I think, about the design. I'm not quite happy with it. I think I would like to see these two ICs like that, and then the resistors and the transistors above it. I'd rather have it maybe a little bit taller than wide, because wide is annoying, but taller is okay. And maybe what I could do is put the display up a little bit, so I've got some components under the display and then a few more on above it. I think that would be nice. Like a. I sent the number to Twitter. I'm looking at it right now. Come on. Oh yeah. Stop reminding me, I've not finished. You're not finished, you lazy bastard, Andrew. You haven't fucking finished. All right. What is the mystery then of this device? Let's run a check. That's a. I need an ERC. There we go. Why can't I make this bigger so I can read the friggin' thing? Ah, oh, fuck's sake. If only we could read what that actually said, then we might have a chance of actually fixing this. Ah, there we go. Implicit power pin, VDD and VSS. I'm trying to think, how do I add this without changing all of the nets? Oh! How do I answer it? I've never used this phone. Hello? No! What happened? Tell you what. Here's the phone. Fortunately, it's a kind of a mobile phone as a desk phone. Hello?
Hello, trying again.
Ah, that's better. Well, welcome. Welcome to the back office.
Thank you for having me.
The quality of this phone is a little bit pants, but I think it's okay. I think you're audible to everybody in the world and the other 5 people who are watching. No, 12. Big numbers for me.
Oh, I didn't check. 12 viewers. Amazing.
12 real-time views. That's an all-time record for me. I'm trying to work out actually how to join the VDD and VSS to my existing ground and 5-volt line. So that's my particular challenge. And I'm thinking of adding solder jumpers, which is a pretty lame way of doing it, but it will work.
I'm not sure about Eagle. I've tried it today on CAD, and it looks like you can have a short connection to another pad and assign it to a net, and it will automatically connect.
I have a feeling that this isn't as good as that, so it's going to have to do something like this. Yeah, so Tila, everybody's asking if you've got your pants on. I'm kind of hoping you don't, but my wife is away. But
no webcam for you.
Now, do you know what the difference is between VSS and VDD, or whatever this was missing?
I'm not perfectly sure why they call it that way, but as far as I know, VSS is the same as ground.
I think you're right there. I think it's something to do with MOSFETs. I always see in MOSFET nomenclature they actually seem to use that for something. I think it might, maybe it's if it's filtered power, or I don't know.
I think they do it to differentiate between the actual circuit ground, because if you have transistors or MOSFET, they're often not connected directly to ground, but a little bit above a load or a resistor, and so VSS is just the lower potential with regards to the MOSFET. I think that's the reason, but I'm not totally sure.
I'm glad that I feel like I'm just messing around here most of the time because I don't really know what I'm doing. I just sort of seem to get away with it, and I'm glad. I'm glad when I hear other people talk in the same sort of way.
Sure.
I want to show you guys at home something. I just remembered. If I have got one. No, I'll show you another time. I actually have a product that we actually designed. So we actually I've got away with it so much that we've actually designed real life products that are in shops without any formal electronics education at all. So it just shows if I can do it, anybody can do it for sure.
It's just a question of the learning curve. You have to start somewhere and know people who know something, and then put the pieces together. And after a given time, you will have something, and that's the way it works for me.
Well, I think there's probably quite a few younger people watching as well as maybe the older generation. I feel that life is a little bit like that. You just keep trying something and you always think that maybe you're getting away with it, like you're sneaking through life, like you're pretending that you know what you're doing, and people are like paying you or respecting you or whatever it happens to be for that thing. But I think that's a feeling you probably will always have, that you're cheating somehow. But that's how I feel.
I think it's a certain portion to the daily life, yeah.
So, how you?
Sometimes,
go ahead.
Sometimes it's just a question of finding the point of good enough. You don't have to be good or perfect. Sometimes let's say 80% will do the whole trick you need.
Well, I think also there's an aspect that imposter syndrome, maybe. Yeah, maybe I always feel like I'm an imposter in everything because I do so many different disciplines. I can't even write a CV anymore because it just reads like it's bullshit. It's so bullshit. I suspect maybe there's different types of people. If you went to university, you studied one thing and then you spent 50 years doing that one thing, maybe you pretty are expert in it. You can feel that you're legit. But I guess just that's what learning is. You know what it is? Maybe it's the feeling that unless your education is validated by doing it through university or college, that it's not real education, and that's the problem. That's maybe where this imposter syndrome's coming in, because you taught yourself something. It seems less valuable.
Maybe one aspect. The other thing I found is that things that you learn on a fact basis in school or university is outdated once you leave university, and you have to learn it again with the new technology, new rules, basically. And you get along with the university knowledge only so long, and then you have to find another way and learn new things, develop new things, and sometimes frustrating, and sometimes it's pretty amazing. Some people just get along with the things they have and stress out others.
Well, I feel it's very weird culturally, actually, because sometimes we find it hard to find people to employ because we feel that everybody should have that same either entrepreneurial spirit or whatever it is that we have. And, we have to appreciate that 80% of the population don't think like that. They just want to do a job, have a holiday, have a pension, and that's life for them. That's normal, right? That is actually normal, though. That's what people feel like. Whereas a lot of people, like myself, I don't even understand it.
I think maybe 3/4 of the way is being true about your motives, and just to say, no, it's not my thing, I don't want to do it. And then others can adapt to that and learn their way and just find a pattern that works for both of you.
Yeah. I think I've been I'm just looking at the comments here. I don't know if you're watching them, but yeah. Kev, I'll tell you. I can put you in touch with one of our employees who's pretty good, and he'll say how he started with us, and he did have an electrical background, but he's pretty good at electronics and physical wiring harnesses and stuff from working with us in the same way. And yeah, if you get the right people who think you can. So Kevin, on the thing, yeah, you could be not necessarily qualified electronics engineer, but you could pretty much bloody just pick it up from watching videos. Don't let anybody tell you otherwise, that you need to go to college just to pick up this stuff. It's definitely, you can learn it.
Yeah, absolutely. I think one of the largest steps that you can take is to find that whatever you have learned as a profession might not be your thing, and you have to find something else. And I know a few people who came from, let's say, masonry or woodworking, and they found that they are very good site managers. They can lead people, instruct people, and produce results as a team, and they're pretty happy. Nothing to do with their original profession, but they're happy, and this is the largest accomplishment I think you can find.
I'm pretty envious of people who have found their place, because I'm still always hungry, always trying to find that sweet spot for me, and I've just never managed it. But I'm spending a lot of time at the moment doing R&D stuff, which I really love R&D, and I love doing the YouTube. Actually, it's almost YouTube every evening is like, to me, a real fun job. I think of it as I'm running it the same way I'd run a business. So I plan everything and put processes in, and I could have ISO 9000 for a YouTube channel. But yeah.
Yeah, ISO 9000, separate topic. We should touch that.
Come on, the ISO 9000 is awesome.
Let me put it this way. I have read the current ISO 9000 standards. I think it's from 2015, and it's very good. The basic idea, I love it. It's perfect. It's about communication, talking to people, helping them embrace quality and do things that they say, hey, cool, I do that, I work with them. Perfect. But I've never seen it put into action in real companies. The companies I know only do whatever they need to get the certificate, and that's it. It's rather pointless. I've seen a few companies who have a very high level of quality, and if you ask them for the certificate, they say, sorry, we don't need it. We can do it easily, but we don't need it. If customers have questions, we show them around, they never ask again. They're happy. And so it's a little bit ambivalent, I would say, between quality and certificate. It's two worlds.
I think the way of looking at it, ISO, I know it's a quality standard, yeah, but I like to think of people should be just using it as a blueprint for how you want to even just think about starting your business, your organization. So just thinking about processes, workflow, inputs, outputs, metrics, measurement, just those essential things. Whether or not it'll actually result in improved quality, I'm not sure. I think it will. But it definitely gives people a lot of handle, because, again, young people watching here might be quite naive when they want to start their own businesses and things like that. But they have no framework to actually even operate in, and very soon they just get screwed. So I think it's a pretty good start just to sort of maybe go on a course, like an auditor course, just to kind of get that idea of thinking about measurement and seeing, are we doing a good job, are we doing a bad job?
I think it's a good basis, but what you never should forget as an entrepreneur, getting the ISO certificate is not the goal.
Absolutely, that's it.
It's
Absolutely.
your work, but it cannot be the goal. Then you're doing something wrong.
You've absolutely hit the nail on the head, and I hate that, because so many organizations think it's just about getting the frigging piece of paper, but it's not. It's about just living by the thing that you're saying you're going to do. That's such good value to do it properly, and I hate that when people just I'm going to go for if you say I'm going to do the ISO certification this month, they just sort of shit on it because they think it's a paper getting exercise. But no, that's definitely not the right approach.
I think it's the very same with my current profession. You know, I'm originally an electrical engineer, and I found my way into project management, and we have the same problem. People run around and say, hey, I'm certified from PMI or GPM or whoever, and think that they can lead project teams and have projects succeed. And it doesn't work that way. You need to have the qualification, and then you can apply for the certification. But it's also two different things. It's just the same like the quality certificate. It's just two different things that not necessarily have a causal correlation.
Absolutely, yeah. That's oh gosh, that's some wisdom for people watching. Hope you're learning that. I think that's it. Tilo, we've done it. We've done it. We're 100%. That's the board.
Looks a bit wonky on the right side, but well, nice. I like it.
I'm not quite happy with this little wire I've routed just quite on the edge of the board, though. Might need a little bit of work, but I think
you might risk the electrons falling off.
Yeah, I might. Maybe I'll just make the board slightly wider, and not a problem.
You can always bodge my arm.
Oh, Brian's saying get rid of the solder jumpers. I don't know. Here's my cheat. If I'm going to put the solder jumpers, I just do that. Look. Bang. Now they're closed. Finished. Done. And Brian, the reason they're there is so I can debug part of the circuit by taking it out by cutting those links. There we go. I think this is a pretty good. I think this is a good point to save this and pop it on the GitHub and let if anybody wants to have a play with it. I think that's my solution. I'm not sure whether or not it works, but that's my first attempt.
Looks very nice so far.
Oh, I guess there's one thing that one has to do, and that's to try to radius the edges somehow. Then I can feel that we've made it. Look, there you go. Now it's pretty. Oh no! Keep radiusing till something radiuses. Oh well, that one's wrong. That's for like you can't have a perfect board. You have to always have something wrong that someone else can fix for you. It's something I've learned from an ISO audit or TUV audit or any audit. Give the auditor something to find and make sure it's something that you're controlling.
Absolutely. If they don't find anything, they will keep on searching.
They'll find the bad stuff.
From dusk to dawn.
There we go. Well, I've had a lot of fun, and I don't know. I think that's a good to call it a day. I hope everybody at home and Tilo, you are satisfied with your PCB observations today, and maybe in a future.
I can only speak for myself, but yeah, absolutely.
And in a future video, I might just try to make this, because it looks like I probably have most of the parts apart from the decade counter. So I feel I'm obligated to build this thing now with my milling robot. But yeah.
Oh, I'm looking forward to that.
Very, very nice speak to you, Tilo, and I'm looking forward to seeing you in Germany at some point. No doubt, on my travels, I shall make sure I pass near wherever you happen to be.
I'll be happy to meet you. If I ever have a job or a travel to the island, I will give you a visit. We'll have a pint or two, and of course enjoy the night.
Absolutely. Awesome. Well, thank you everybody at home. Thank you, Theo, and hope that's been of some use to you all. I'll probably post this up on the usual Backoffice channel thing. And please feel free. I'm going to post this on GitHub if you want to have a mess around with the drawing and try to make it better, or see what you can do with it. That would be fantastic. And also, there's one Backoffice box left on the shelf. If anybody wants to pick that up, let me know. Send me, ping me if it's not already used, and I'll send you the quote to get the 50% discount, as if you were a Patreon patron. As ever, thank you for watching.